Hello students, welcome back to Akshar IT Foundation classes. I'm your chemistry faculty, S. Mohan. So students, in the 8th class, we are doing the solution chapter in the synopsis 4, and in the last class we discussed about the normality, right? So normality, definition, problems, already we discussed in the last class. Today's topic is mole fraction. What is mole fraction? Students, mole fraction means what? The number of moles of solute present in total number of moles of solution. Okay, did you understand? No? Chalo. Once I'll explain it with an example. So see now. So yes, students, here for example, we have the solution. Okay, you know that solution consists of solute and a solvent. Okay, so we can see now. Okay, so this is a solution, right? So solution consists of two components, right? One is a solute, right? Second one is what? A solvent. Okay, now generally you know that number of moles. Moles is what? The unit of to measure the mass in the chemistry, right? So let the number of moles of solute, let me take the solute is A, solvent is B, right? So the number of moles of solute is Na, number of moles of solvent is Nb. Now what the mole fraction states is, mole fraction is of two types. We can calculate the mole fraction of A, means what? Solute, and we can calculate the mole fraction of B, that is solvent. So mole fraction of the solute is the ratio of mole fraction of solute by, number of moles of solute by total number of moles of solution. So moles of solute plus moles of solution. Now if you want mole fraction of solvent, so number of moles of solvent by number of moles of solution. So that's all. So XA is equal to Na by Na plus Nb. Here it is not called as X, actually it's called as a chi, but for your understanding I'll tell X. So let mole fraction is denoted by this letter chi, but let's take as X. So XA is equal to, means mole fraction of solute is equal to Na by Na plus Nb, and mole fraction of solvent is equal to Nb by Na plus Nb. So see here Na by Na plus Nb, Nb by Na plus Nb. So see here now number of moles, okay, is so here you see mole fraction of here you see mole fraction of a solute means what? A, Xa is equal to Na by Na plus Nb, mole fraction of B is equal to Nb by Na plus Nb. And one important concept here it is that, okay, the sum of the mole fraction of A and B, means solute and solvent, is equal to 1. This you have to remember, very important concept in solving the problem. What is that concept? Mole fraction of solute plus mole fraction of solvent is equal to 1. Is equal to 1. When you add these both, that should be equal to 1. So generally it is useful in solving the problems. So see here now. So see here now. So the sum of the mole fraction of all the components of the solution is always 1. Means what? Xa plus Xb is equal to 1. So this is about the mole fraction. So very simple, okay, method. This is a mole fraction. Okay. So now students, I'll explain you some problems from your material. Okay. So mole fraction you can see in your material page number 37. Okay, once if you open the page number 37, you have the mole fraction of definition. Okay, so it's a down the ratio between the number of moles of solute. Okay, so see here the ratio between the number of moles of solute to the total number of moles of solution is called as a mole fraction of the component. Okay, the formula is also given, see in your page number 38. Xa is equal to Na by Na plus Nb. Xb is equal to Nb by Na plus Nb, and it's given that Xa plus sum of the mole fractions of components is equal to always 1. Xa plus Xb is equal to 1. Clear? So that is about the mole fraction. Okay. Now let us solve some numericals, right? So see students here, see the page number 39 in your material. Page number 39 in your material. So problem number 1 is given 3.65 grams of HCl. Okay. So see here page number 39. Okay. Problem 1. In the problem what is given? So see now problem what is given? 3.65 grams of HCl. So 3.65 grams of HCl is dissolved in 16.2 grams of water. 16.2 grams of water. Now what they are asking to find? They are asking to find the mole fraction of a solute, mole fraction of a solvent. Both they are asking to find. Clear? Now here you see 3.65, 16.2, which is in lesser quantity. 3.65 is lesser quantity. So your solute is HCl and the solvent is water. Solute is HCl, solvent is water. So let us take this is solute. So solute we denote by A, okay, and this is solvent we denote by B. Now weight of solute WA is how much it is given? 3.65 grams, right? Now molecular weight of a solvent is given. It is not given. You have to find molecular weight is sum of the atomic weights of the all the elements. Hydrogen atomic weight is 1 plus chlorine is 35.5. 1 plus 35.5 is equal to 36.5. Correct? So 36.5. Okay. Now number of moles. Mole is equal to what? Weight by molecular weight. So now 3.65 divided by 36.5. So ones are tens. So that is equal to 0.1. N is equal to what I got here? Number of moles of solute is 0.1. Understood? Now you do that one. See now. Weight of a solvent is equal to 16.2 grams. Molecular weight of solvent water. Water formula is what? H2O. What is the molecular weight of the water? 2 hydrogens, 2 ones are 2 plus oxygen is 16. 2 plus 16 is equal to 18. So molecular weight is 18. So number of moles is equal to weight by molecular weight. So that is 16.2 by 18. If we cancel 9s are 10s. So that will get 0.9. So NB I got 0.9. So Na number of moles of solute is 0.1. Number of moles of solvent is 0.9. Now what is the mole fraction formula? Mole fraction formula is mole fraction of solute is Na by Na plus Nb, and mole fraction of solvent is Nb by Na plus Nb, right? Now this formula I'll write here. So mole fraction of solute is equal to Na by Na plus Nb, and the mole fraction of solvent is equal to Nb by Na plus Nb, correct? Now what I got here? Na 0.1, Nb 0.9. That I will substitute here. Now mole fraction of solute is equal to 0.1 by 0.1 plus 0.9. So that is equal to 0.1 by 0.1 plus 0.9, 1. So therefore mole fraction of solute is equal to 0.1. This is my answer. Okay. And here XB, mole fraction of solvent, is equal to here 0.9. 0.9 by 0.1 plus 0.9, that's equal to 0.9 by 1. So XB is equal to 0.9 by 1 is 0.9. This is my answer. Now I solve the problem. Whether my answers are correct or not, to check what can I do? I give one formula to you. That is XA plus XB should be equal to 1. Now see here, XA is equal to 0.1. Now I'll add this both. 0.1 plus 0.9 is equal to 1. So therefore my answer is correct. Clear? So this is a method of solving the problem. Okay. So this is of course example problem. Now let us see some exercise problems. Okay, on the mole fraction. So students, here exercise 1, page number 44. In the page number 44, you can see the 9th question. You can see the 9th question. Okay. So 9th question you see page number 44. Page number 44, 9th question. Okay. So ninth question is what? 6 moles of solute is present in 100 moles of solution. Then the mole fraction of the solute is. Okay. So 6 moles of solute. So 6 moles of solute is denoted by A. So therefore Na is equal to 6 moles. Is present in 100 moles of solution. Solution is what? Na plus Nb. Na plus Nb is equal to solution is given 100 moles. Now what they are asking to find? They are asking to find the mole fraction of solute. Mole fraction of solute is what? Xa is equal. They are asking to find. But what's the formula? So Xa is equal to Na by Na plus Nb. Correct? So now Xa is equal to Na is equal to 6 by Na plus Nb is equal to 100. So 6 by 100 is equal to 0.06. So our answer is 0.06. Right? Now see the option, second option. So you can see the second option, ninth one, 0.06. So the answer is second option, 0.06. Clear? Right. Now similarly, let's do the 10th sum. 10th sum. Same page number 44, question number 10. So here it is given 60 grams of urea is dissolved in 90 grams of water. So see students now, what is given here? 60 grams of urea. See here you need to know the formula of urea to find the molecular mass, right? So urea molecular formula is NH2CONH2. This is a urea formula. You have to know this one, students, otherwise you can't solve the problem. So 60 grams of urea is dissolved in 90 grams of water. 90 grams of water. What's the formula of water? H2O. Correct? So this is the 90 grams of water. Now here you see 60 here, 90 here. So here which is lesser here? 60. So here this is a solute. What it is? A solute. So it is denoted by A. And here 90 is more. So this is a solvent. Okay. So solvent is denoted by B. Clear? Now see here now. Weight of a solute is equal to 60 grams. It is given. Right? Next, gram molecular weight of a solute is given. We have to find. So how to find? Molecular weight is nothing but a sum of the atomic masses of all the elements, right? So see here, how many nitrogens are there? 2 nitrogens. Each nitrogen atomic mass is how much? 14. So 14 2s are 28. So 2 nitrogens atomic mass is 28 plus hydrogens. Here 2, 4 hydrogens are there. Each hydrogen mass is 1. So 4 ones are 4 plus how many carbons are there? Only 1 carbon. Carbon mass is 12 plus 1 oxygen is also there. Oxygen molecular mass is, atomic mass is 16. So 16. Okay. Now you add these both. 28 plus 4, 32. 32 plus 12, 44. 44 plus 16, 60. So this comes to 60. Okay. And what's the number of moles formula? Weight by molecular weight. Weight by molecular weight. So weight is how much? 60. Molecular weight is how much? 60. 60 by 60 is equal to what? 1. So therefore, number of moles of solute is equal to 1. So we got Na. Clear? Now you can find that one now. Your weight of solute Wb is equal to 90 grams. Okay? Molecular weight of solute. Water, 2 hydrogens, 2 ones are 2, 1 oxygen, 16. 2 plus 16, 18. So number of moles is equal to what? Weight by molecular weight. Weight is how much? 90. Molecular weight, 18. 18 ones are 18 fives are. So I got Nb is equal to 5. Okay. So I got Na, number of moles of solute. I got Nb, number of moles of solute. Now what I want to find? Mole fraction of the solute. Mole fraction formula is what? Mole fraction formulas of solute is what? Xa is equal to Na by Na plus Nb. This is a mole fraction of solute formula. But now what I got? 1 and 5, right? So 1 and 5. Now I'll substitute here. So XA is equal to 1 by 1 plus 5. That's equal to 1 by 6. Okay. So mole fraction of solute is equal to 1 by 6. Check the answer. Question number 10, yes. So second option you see here, 1 by 6 is there. Is there? Okay. So 1 by 6 is the right answer. Understood? Chalo. Now next one is molarity limit. Now 12th question. Now let us see 12th question. So 12th question is again mole fraction of solute in 2.5. Okay. This one we do. So see here, mole fraction of solute in 2.5 moles of aqueous solution. 12th question. Okay. What is given? Mole fraction of solute we have to find. Mole fraction of solute means what? XA we have to find. Okay. Of a solute in 2.5 moles of aqueous solution, solute moles is given, means Na is given. Na is equal to 2.5 is given. And what is the solvent is not given, but it's given in aqueous solution. Aqueous means what? Water. So water solution. So water solution means what? Nb we need to find. How can we find? So here 1000, because 1 kg water if you take 1000 and water molecular weight is 18. Just now we calculated no in the previous one. See here, water is 18. Okay, so we got 18. If you cancel, how much you'll get? Let us check. 18 5s are 90. Okay, 100 minus 90 is 10. So again 100. 18 5s are. Okay, 10 will be left. So point. So we'll get 55.55. I'll get. So this is Nb. Okay. So now XA, what's the formula of XA? Mole fraction of solute. Na by Na plus Nb. Correct? So now XA is equal to Na. Na is what? 2.5. It is given in the question itself. Divided by, here Na is 2.5 plus Nb. What we got here? 55.55. Okay. So what you'll get here? 2.5 by 55.5, 2.5. That is 58. So approximately I'll get 58.05. So I'll take 58 here. Okay. So what is given answer? 22.5 by 58 is there? Not there. Okay. Now we have to cancel it. Okay. So now we have to cancel it. So on cancelling, what will get? See here now. 2.5 by 58. I write this as 250 by 580. Let's check. Okay, 250 by 580. Okay, so 0 point. Then I'll get 0 here. 5 5s are 25, but 580 is there, so 5 4s are. Okay, so 400, 4 8s are 32, 3, 4 5s are 20 plus 3, 23. Right? So 0, 8, 1. I'll get 180 here. Okay, I'll put 0. Now 5 4s are 20, 5 3s are. Okay, 3s are. 3 0 0, 3 8s are 24, 2, 3 5s are 15 plus 2, 17. Okay, 0 6, 60 I'll get. Okay, so 0.43 I got the answer. Right? So now if I cancel 2.5 by 58, I'll get 0.43. Whether the option is there or not, once you check. Yes, 12th one. 12th option is 0.43 got here. That's the second option. Can you see the second option? So second option is 0.43. Right? Okay. So like this you can solve the problem. Right. Now let us see the 13th one. Can we do? 13th one is little typical problem. Lot of calculation will be there, I think, in the 13th problem. It's looking like that. Mass of ethanol to be added to 1 kg of water to have the mole fraction of ethanol equal to 0.2. Oh, the problem will be little typical. Typical means what? Calculation part is more here. mass of ethanol to be added to 1 kg of water. So see students, here 2 are there. One is ethanol. So ethanol is a solute. Ethanol formula is C2H5OH. Okay. So this is a solute. Okay. Solute means what? A you have to take. Is added in 1.0 kg of water. So next is given water. Water formula is H2O. And let we take this is a solvent. So solvent is B. Next, what is given here? The mole fraction of ethanol is equal to 0.2. So mole fraction is what? XA is equal to given as 0.2. This is given to us. Okay. Now what we need to find is here weight of water is also given. So weight of water is given 1000 grams. Means water 1 kg. This is given. Now here mass we need to find, means weight we need to find, W. We don't know. But molecular weight you should know. 2 carbons are there. Each carbon is 12. 12 2s are 24. Plus here 5 plus here 1. Total 6 hydrogens are there. Each hydrogen mass is 1. 1 into 6 is 6. Plus 1 oxygen is there. Oxygen is 16. So 24 plus 6, 30 plus 16, 46. So molecular weight is equal to 46. This I got. Okay. Now here molecular weight, you know, molecular weight is equal to of water is 18. Now number of moles of solute. Na is equal to weight by molecular weight. So weight we don't know. So put as M by molecular weight is 46. This is Na. And here Nb, weight by molecular weight. Weight is 1000 divided by 18. So that is equal to 55.55. How I got here? Already we did it here. Somewhere. Here. 1000 by 18, 55.55. You have to remember. Okay. Now this information we have, this all you substitute in the formula. Okay. What's the formula? Formula is what? For mole fraction. Mole fraction XA is equal to NA by Na plus Nb. Correct? This is a formula. Now if you see here, XA is given 0.2. So now write here 0.2 is equal to Na. We don't know the Na. So for now, let's take Na only. Okay, Na, let's take Na divided by Na plus Nb. Okay, Nb I got 55.55. Correct? So I'll write 55.55. Clear? Now what I do, I bring this a denominator this side. So it becomes multiplication. So this becomes 0.2 is into this one. Na plus 55.55 is equal to your Na is there. Na. Clear? Now I'll multiply 0.2 into Na, 0.2 Na plus 0.2 into 55.55. 55 2s 110. That is 110. So this approximately I think I'll get 11. I'll get approximately. Correct? 2 5s are 10. 1 2 5s are 10. 1 11. 1 2 5s are 10. 1 11. 2 5s 10 1 11. Okay. I'll get 11.11. Okay. I'll write 11.11 is equal to your Na is there. Na. Are you following? See, calculation part is very important here. Okay. Now what I do here, plus 0.2 Na is there, I am taking that side. So this becomes 11.11 is equal to Na minus that is going to there 0.2 Na. Okay. So 11.11 is equal to, if I take Na common, then here 1 minus 0.2. So 11.11 is equal to Na into 1 minus 0.2 is 0.8. Okay. Now this I'll bring here 11.11 divided by 0.8 is equal to Na. You have to calculate this one. So this I'll get 111 by 8. This I can write like, so I'll write this one as 111 by 8. So 111 by 8, how much I'll get? 8 ones are 8. So 3 will be left 1. 8 threes or 8 fours are 32. Approximately I'll get 14. Okay. So I'll be getting here, the answer is equal to 14. So Na is equal to, I'm getting approximately, I'm getting the answer is 14. Okay. Now they're asking to find the mass. Asking to find the mass. So I have a formula for number of moles is equal to mass or weight by molecular mass. Weight by molecular mass. So Na is already given. Na is equal to 0.2 is given. So what I do now? I'll write 0.2 is equal to weight by, sorry, one minute. I've done little mistake. Okay. So number of moles is equal to weight by molecular weight, okay, of Na. Number of moles, what I got here? 14 I got here. This is 14, right? So then what I write? 14 is equal to weight, I don't know, but molecular weight is 46. Yes. So molecular weight we are calculated here. Where we calculated molecular weight? Here, 46. Okay. So now bring this one here. So 14 into 16 is equal to W. Now multiply. Hey, yeah, lot of calculation is there here. So 14 into 16, right? 6 4s are 24, 2, 6 1s are 6 plus 2, 8, correct? So this is 14. 4, 2, 224 should be your answer, but it is not there. Somewhere calculation part is done. Oh, sorry, yaar. Here 46 this is. This is 46, no? So this should be 46. So 14 into 46 approximately. Chalo, once again we do the calculation. This should be 46. So 46 into 14. Right? 4 6 are 24, 2 4 4s are 16 plus 2 18. Right? 1 into 6 is 6, 1 5 is 5. Okay. So 4, 14, 1. Again, we are mistaking somewhere. 4 6 are 24, 2 4 4 are 16 plus 2 18, 4 1s are 4. 4 6 are 24, 4 2 4 4 are 16 plus 2 18. Correct. Now 1 into 6 6, 1 into 4 4. Yeah, right. Now 4 8 plus 6 14 1. So 4 5 6 644. Okay, approximate answer. So 644, very close number is what? 638. Okay, so you can take the answer 638 because students here we are avoided the points here. Okay, so we are avoided these points here. So approximately I have taken the round figure as a 14. Okay, so that's what I got the answer. Yes, 644, but you should get nearby answer is 638.8. So the answer is 638.89 is the right answer. Clear? So that is about the mole fraction, students here. So with this chapter is done. Okay, the solution part is done. So and some other sums are there. You can practice in your my task. Okay, my task problems are there in the page number 46. You try the problems. So normality and mole fraction. So with this we completed this topic. Okay, but keep on practicing. Then in the next class we start the new chapter, that is mole concept and stoichiometry. This is also very important chapter. Okay, so until, take care, bye, see you.